Okay, so this is the second video on calculations of pH. In this video we're going to calculate the pH of a weak base solution. So we might as well get started. Question is, calculate the pH of a 2.34 times 10 to the minus 4 mole per liter solution of calcium hydroxide, which is identified as a strong base, which you'll hopefully recognize as a strong base, a group 2 metal hydroxide. So pretty straightforward, much like the strong acid calculation. Calcium hydroxide is a strong base, so it dissociates fully. So if it dissociates fully, it's going to look something like that. So the dissociation of calcium hydroxide yields 2 moles of hydroxide ions. That's our ion of interest. And so the concentration of hydroxide ion in this solution is going to be 4.68 times 10 to the minus 4. Okay, so if we know the hydroxide ion concentration, we can calculate the pOH. So pOH equals negative log hydroxide ion. So that's negative log 4.68 times 10 to the minus 4 moles per liter. And that comes out as 3.330. So the pOH is 3.330. Now if you remember, 14 equals pH plus pOH. We're interested in pH, so pH equals 14 minus pOH. So that equals 14 minus 3.330. And so the pH of this solution of calcium hydroxide is 10.670. So strong base dissociation yields our known concentration of hydroxide, and we can proceed from there to calculate pH. So pretty straightforward. Well, how about if it's a weak base? So here's a weak base dissociation. Calculate the pH of 2.34 times 10 to the minus 4 mole per liter pyridine. So same concentration of this basic solution, but it's a weak base. Pyridine is a weak base. And so in this case, we proceed as we did with the weak acid. So we write a weak base dissociation. So there's my weak base dissociation. The base in water gives this cation. So to identify the cation, just add an H plus at the end. That's typically the way it's shown. Plus hydroxide ion. So again, there's our ion of interest, the hydroxide ion. We need an ice table. Initial concentration is filled in first, and that gives us our equilibrium concentrations. This is what we need because we want to write a KB expression. And so before we do that, though, we can quickly check our initial concentration, 2.34 times 10 to the minus 4, and our KB, 1.5 times 10 to the minus 9. That's clearly going to follow the 100 rule. So we can make our assumption. So we'll do that first because KB is so small. Assume that 2.34 times 10 to the minus 4 minus x equals 2.34 times 10 to the minus 4. So that allows us not to have to solve a quadratic equation. So weak base equilibrium expression, Kb, concentration of our cation C5H5N plus, multiplied by concentration of hydroxide ion, divided by the concentration of our base. And now we can substitute everything in. And so our Kb value, whoops, lost it there, Kb value is 1.5 times 10 to the negative 9. Negative 9 equals x times x divided by 2.34 times 10 to the negative 4. So x squared equals 3.51 times 10 to the negative 13. X equals 5.92 times 10 to the negative 7. So that is our hydroxide ion concentration in moles per liter, 5.92 times 10 to the negative 7 molar. So from that we can calculate the pH, and we'll do it the other way this time. We'll calculate the hydronium ion concentration first. So remember, hydronium equals Kw divided by hydroxide ion concentration. So that's 1 times 10 to the negative 14 divided by 5.92 times 10 to the negative 7. And that gives us a hydronium ion concentration of 1.69 times 10 to the minus 8 moles per liter. And from that we can calculate pH. pH negative log hydronium ion is negative log of our concentration, 1.69 times 10 to the negative 8 moles per liter. And that gives us a pH of 7.77. So again, if we think about the concentrations, so as compared to, for equal or same concentration of the solution, the pH of our calcium hydroxide was 10.67 versus the concentration of the same, or the pH of the same concentration of a weak base solution is much lower. So the percent dissociation is less, and that is the percent of hydroxide produced is less because the base is weak. And so that concludes this video.